On this Ram 1500 with the 5.7 gas engine, P0072 is an ambient air temperature sensor signal circuit low fault. In plain terms, the controller may be seeing the outside air temperature signal pulled too low. The driver may notice an incorrect outside temperature display, and depending on how the vehicle uses that data, related comfort or powertrain decisions can be affected. The broad fault areas are possible sensor trouble, a poor connector, a signal circuit shorted low, a sensor ground issue, or less often a controller side problem. Treat any other stored codes as context, and if other codes are present, check what they mean first instead of chasing this one in isolation. Before getting into circuit testing, start with the basic system checks. Look for any applicable bulletins, known cases, or flash updates that match the DTC or the symptom. Then check the ECU for battery voltage faults, because low battery voltage can cause false or misleading DTCs. Since P0072 is a circuit fault, handle circuit faults before any rationality or performance-style diagnosis. Next, go straight to the component connector condition. Make sure the ambient temperature sensor connector is fully seated and locked before unplugging it. Then disconnect it and inspect for water intrusion, pushed-out terminals, damaged terminals, corrosion, burn marks, or spread terminals. Keep that same mindset through the rest of the diagnosis. Before condemning an ECU, carefully check the connectors in the circuit path for water intrusion, spread terminals, pushed-out terminals, burnt terminals, or corrosion. Read and record all DTCs and captured operating data, and save a vehicle scan report in case you need it later. Then review the captured conditions, the monitor gates, and the set conditions. Clear the codes and operate the vehicle or system under similar conditions to see whether P0072 comes back. If the fault returns or is present, continue with the circuit diagnosis. If it does not return, treat it as intermittent and avoid guessing. For an intermittent P0072, use the captured data and run the vehicle in similar conditions so the diagnostic has a chance to run. Before digging deeper, check for related flash updates and bulletins. If nothing applies, wiggle test the harnesses that carry the circuit while watching for the code to become active or for scan data to change. If you are using a scope, back probe the temperature sensor signal circuit and watch the voltage during the wiggle test. If you cannot watch the scope live, set a trigger to catch the event. Voltage above 4.9 volts for an intermittent circuit high fault or below 0.1 volts for a circuit low fault. Make sure the battery or batteries are properly charged, operating correctly, and have good connections. Also identify and check the chassis grounds related to the system you are diagnosing. From there, choose the test method that makes sense for the vehicle in front of you. You do not need to perform every listed method. Pick the best path based on access, ease of testing, and the test equipment available, but do not skip wiring checks when the results point that direction. This temperature sensor circuit is typically a variable resistor on a normal 2-wire 5.0-volt sensor circuit. As a general rule, a voltage reading above approximately 4.9 volts would set a circuit high or open fault, and a voltage below approximately 0.10 volts will set a circuit low fault. For this P0072 path, the low fault threshold is typically in the 0.1 volt range. The high side threshold is typically in the 4.9 volt range. That is why the diagnosis is aimed at finding whether the signal is being pulled low by the sensor, shorted to ground, shorted into the sensor ground circuit, or being misread after the wiring checks good. Even though P0072 is the circuit low episode, keep the rationality logic in the back of your mind so you do not mix test paths. The performance style monitor runs with the ignition on after an 8-hour cold soak on the previous engine off cycle, and the ambient air, intake air, and engine coolant temperature values are above -64 degrees C, -83 degrees F. A performance fault is based on the sensor signal being irrational, typically not within 10 degrees C, 15 degrees C, 18 degrees F, 27 degrees F, of the other engine temp sensors. Circuit load testing is still the priority for P0072, but that context helps separate a pulled low circuit from a drifted or stuck sensor reading. One complete way to test the circuit is with the electrical test lead kit connected to the temperature signal and sensor ground circuits at the sensor harness connector. Move the switch between open and closed while watching the scan tool. In the open position, the circuit high fault should set, and the sensor voltage should be 5.0 volts. In the closed position, the circuit low fault should set, and the sensor voltage should be 0.0 volts. Then use the adjust position to vary resistance, while monitoring the ECU signal voltage on the scan tool. If the circuit responds correctly open and closed, the ECU and wiring are being exercised properly, so the sensor or its immediate connector becomes the main suspect. Inspect the sensor connector closely before condemning the sensor. If the signal stays low, or only the circuit low fault sets, look for the temperature sensor signal circuit shorted to chassis ground or shorted to the sensor ground circuit. If the signal circuit is not shorted, check the related connectors again before calling the ECU faulty. If the complete circuit check points to resistance in the circuit, the affected circuit should typically be less than 3.0 ohms. If all connector checks are clean and the circuit checks support it, ECU replacement is supported at that point. If you are using a DVOM, first verify the temperature sensor and ECU harness connectors are connected and locked. Turn the ignition on, back probe the temperature sensor signal circuit at the sensor connector and measure the voltage. If the signal is between 0.1 and 4.9 volts, the sensor signal is likely a legitimate reading. If the circuit fault is active and the scan tool voltage does not match the DVOM voltage, the ECU is suspect. If the signal is a constant 0.0 volts, that points toward a signal circuit shorted to ground and open between the ECU and sensor, or possibly a faulty sensor on an active circuit low fault. If the signal reading has a constant voltage above 6.0 volts, that points toward the signal circuit being shorted to another voltage supply. If the DVOM result sends you into circuit low isolation, disconnect the temperature sensor and ECU connectors as needed and check the temperature sensor signal circuit for high resistance and short to ground. To check the temperature sensor side, move the test lead over and back, probe the temperature sensor ground circuit at the temperature sensor harness connector. For an active circuit low fault, disconnect the temperature sensor connector while watching the scan tool for the circuit high fault to become active. If the circuit high fault becomes active when the sensor is unplugged, the sensor is most likely faulty. If the circuit high fault does not become active, disconnect the ECU connector to isolate the circuit, then check the temperature signal circuit for continuity to chassis ground and to the sensor ground circuit. If continuity is found to either one, repair the signal circuit short to ground or short to the sensor ground circuit. If the signal circuit is not shorted and the connector checks are clean, the ECU is the remaining suspect. If testing moves you into the typical circuit high side of the shared circuit check, disconnect the temperature sensor harness connector and measure the temperature sensor signal circuit voltage with the ignition on. The signal circuit voltage should be between 4.9 and 5.6 volts. With an active fault, monitor the scan tool and connect a jumper across the terminals with the ignition on. Typically, the temperature sensor signal voltage should change to 0 volts on the scan tool with the jumper in place. If voltage data is not available, the circuit low fault should set with the jumper in place. Then check resistance of the temperature sensor signal circuit and temperature sensor ground circuit. Typically, the circuit resistance should be less than 5.0 ohms. For the typical performance or rationality check, disconnect the temperature sensor harness connector and connect the electrical test kit leads to the sensor harness connector. Move the switch on the tool to open. The signal should read 5.0 volts and a circuit high DTC should be active or pending on the scan tool. Next, flip the switch to the closed position. The signal should read 0 volts and a circuit low fault should be active or pending on the scan tool. If there is voltage present between 0 and 5.0 volts with the test tool in the closed position, Find which circuit has resistance by moving the test lead from the sensor ground circuit to a good chassis ground. Then isolate the suspect circuit and measure resistance between the sensor and ECU harness connectors. If no resistance is measured, check the connectors in that path for spread, dirty, or corroded terminals. If the circuits check good, move on to verifying whether the issue is with the temperature sensor or the ECU. When the path points toward the ambient air temperature sensor, verify it with the temperature and resistance information when you can. The actual resistance can vary +/10% from the values in the table. Key checkpoints are -40°C/40°F/345, 26 k ohms/lowest possible temperature reading, -10°C/14°F/53, 38 k ohms/logical temperature values, -5°C/23°F/40, 89 k ohms, 0°C/32°F/31, 56 k ohms, 5°C/41°F/24, 55 k ohms, 10°C/50°F/19, 24 k ohms, 15°C/59°F/15, 22 k ohms, 20°C/68°F/12, 13 k ohms, 25°C/77°F/9720 ohms, 30°C/86°F/7780 ohms, 35°C/95°F/6370 ohms, 40°C/104°F/5200 ohms, and 150°C/302°F/181 ohms/highest possible temperature reading. If a temperature table is available, dial the test tool to a table resistance value and watch the scan tool for the proper reading while you vary resistance. If the actual temperature can be acquired or reasonably estimated, measure resistance across the temperature sensor terminals and compare it to the table. If a table is not available for the sensor being tested, connect the electrical test kit leads to the harness connector, flip the switch to adjust, turn the ignition on, and slowly adjust resistance while watching scan data. If the temperature or voltage value changes as resistance is varied, that indicates the temperature sensor is likely faulty. To verify an ECU failure, open and short the circuits while monitoring signal voltage and fault codes. If the expected voltage readings or codes do not occur and the circuits are not shorted or open, that points to a faulty ECU. If measured resistance from the AAT sensor does not meet the table values, the AAT sensor is individually serviceable. Replace only the sensor, not the entire mirror assembly. Keep repair verification separate from the testing. If the AAT wiring was repaired, the sensor was replaced, or the BCM connector was disconnected during testing to correct an active DTC, the vehicle must be driven for a minimum of 5 minutes above 15 mph, so the AAT temperature signal updates before the DTC will go stored and can be erased. After that, verify the repair and confirm P0072 stays gone. The takeaway on P0072 is simple. Prove the connector first. Prove whether the signal is being pulled low by the sensor or the wiring, and only condemn the ECU after the circuit and connector path checks clean. For more diagnostic training, visit stepdiagnostics.com.